browser actually executes your script. So as soon as you hit a site, it downloads your script. So right at the extreme left, the browser gets your source code, it's plain text. Yeah, so here, like I was saying, you should probably draw your attention to the fact that the entire thing is running on the UI thread. And the browser actually holds up your processing, right? So as soon as it encounters a script tag, it actually puts everything else on hold, downloads the script, executes it, and then continues, downloading the rest. The reason it does that is because you never know what you do in script, right? So you might download some script, the script might actually extend your DOM, it might add like more tags and stuff, which might actually have an impact on, what happens when the browser processes the rest of your document. So for that reason, the browser will actually stop processing and then, execute your script. Another probably important area here is the fact that the communication between your JavaScript engine and the browser, goes through this intermediary component called, it's not a component, it's a process called marshalling, right? So anytime you say document.get element by ID or something, and you get a reference to that DOM element, you're actually, going through the marshalling layer. So if you assign a, let's say some element or HTML equals some string, you're actually going through a marshalling layer in IE8. And that has very important performance implications, which is what we'll look at next. So when we talk about performance, there is, if you look at the industry in general, right? If you are kind of observing what kind of happens in the JavaScript engine world and all that, there's a lot of focus on on JavaScript itself, right? So there are performance benchmarks which measure how fast a particular JavaScript engine is. There are metrics around that and so on. But it actually turns out that when you talk about performance for web applications, well, JavaScript is a key aspect, but that's not the only aspect, right? That's not there are like so many other subsystems which actually have an important say in what kind of user experience the user has when using the browser. So you have a networking component which is, as you might expect, it's responsible for downloading your resources on the web. HTML, which parses your HTML doc, CSS parses and verifies your CSS style sheets. Collections is basically a subsystem which handles additional metadata that you store in your HTML document. So whatever you put in your meta tag, or if you extend your DOM and put an expander property, things like that are actually stored in the collections subsystem. The DOM subsystem is the system that basically provides you the programmability, right? All the APIs that you have available on the DOM elements. So that is basically provided through the DOM subsystem. Formatting, block building, and layout are all responsible for actually, laying out your entire document. So basically, all your HTML elements are, it's a block-based layout system, right? So it basically translates into little blocks that get laid out in a particular way. So the formatting, block building, layout system are responsible for that, and display is actually a very, very big piece. I have a little graph here which kind of shows, basically, when the IE team was developing or working on IE9, they kind of did some analysis on, they picked like the top 5 sports sites, right? And they kind of try to do an analysis as far as performance, as far as how much time is spent, right? In the different subsystems that we just saw across all these 5 sports sites. So we can almost kind of see a, kind of a signature for each, a unique signature for each site, right? And there is of course a difference in the absolute total time that was taken for, rendering one particular page. And also you can see that the composition of the different slices for each particular subsystem is also different, right? But there are some patterns that you can see. For example, this particular piece right at the top, seems to take a fair amount of time, at least in a couple of those sites. The big red piece here that you see is JavaScript. And one piece that at least I found surprising when I looked at this was this black piece here. See, this here, and here has a pretty big black piece. This is for IE8, okay? So marshalling seems to be taking a surprisingly long amount of time in all these sites. So if you kind of aggregate the whole thing and take a look at where all the time is spent, you can see that rendering is a pretty big chunk, right? Probably the 3 big chunks are rendering, JavaScript, and surprise, surprise, marshalling. So this kind of gives you an insight into why Microsoft or the IE team kind of focused on, for example, with rendering, right? So if you attended the Harish session or any of the HTML5 sessions for IE9 today, there's a lot of talk about hardware acceleration. So the key reason is that because an extraordinary amount of time is actually spent in rendering, so hardware acceleration helps with that. The JavaScript engine in IE9 has been completely rewritten, for that reason. So like we saw, right, many of the rich user experiences involve creating web applications with gigantic, code bases in JavaScript. And marshalling is something that has been dealt with as well. So with that, let's talk about IE9s, which, if you notice, if you were quick, did you catch that? That was the code name of IE9's JavaScript engine is actually called Chakra, which I think is pretty neat. So the big new feature in IE9's JavaScript engine is that your JavaScript code actually gets compiled to native code. We saw that in IE8 it was a purely interpreted JavaScript engine. So with IE9 we have code compilation actually happening. So when we talk about code compilation, it's not a pure code compilation JavaScript engine. So it's what is called as a hybrid JavaScript engine. So there is interpretation. We'll see where exactly that fits in. Compilation happens on spare CPU cores. So again, one of the philosophies with IE9 is we really need to use the full power of the PC, right? So it turns out that a vast majority of the systems, it's very hard to see a computer today which does not have at least 2 cores, right? And quite often more than 2. So IE9 is designed to leverage that, right? Take advantage of that. So compilation actually happens on the spare CPU code that is available, and also on downtimes on the UI thread. Like if you're just reading, it might use that time to compile your JavaScript. Interpreter is still there, right? It's not gone. So interpreter is there for quick startup. The reason is because it's actually a trade-off. Compilation is great. So once you have JavaScript code that is compiled, now you have native code. It runs as fast as it can run. Unfortunately, compilation takes time as well. Probably not very fast, execution of that code, but the user experience will be there. As in, the site will load and start running, right? So for that reason, the interpreter still exists. So this is your new pipeline. So you can see that there are a lot of similarities with the previous one. So we have the browser, parser, bytecode generator, we have the interpreter as before, and we have the JavaScript libraries. So the new pieces here are the compiler, right? So basically the compiler is a new component that is there in Chakra, and that is responsible for generating machine code. So yeah.
Let's say if you have a JavaScript and it is ready to change in future.
Sorry?
You have a JavaScript and how do you handle versioning with compilation?
So so when you compile, right, this is purely a runtime operation. So when you're visiting a page, it loads the page. So it doesn't compile everything. So there's a little bit of heuristics built into the engine to determine where do you get the biggest bang for the buck, right? So compilation is a very CPU intensive task. So the interpreter actually includes a little bit of instrumentation as well. So as it's executing the script, it finds what is called as hot paths, right? It identifies these functions are getting called very, very frequently, and we can really benefit from compiling that. So that piece gets fed to the compiler and generates some machine code.
Do you think that piece is going to improve the performance because anyway JavaScript loading happens only once for the first time,
right?
And then subsequently it will be 3 or 4.
It will be what? Oh, it will be cached, you're saying?
Yes, 3 or 4 kind of equals.
So this whole thing is only an in-memory operation. So once you navigate away from the page, all your compiled code is discarded.
My question is, comparison happens only once when I will make it for the first time, and the JavaScript load is also happen only once for the first time.
No, the compilation happens every time you visit that page. So even if the JS is cached, next time you visit it loads from the cache, that's fine, but it still gets compiled.
Then it is overhead, right?
So that's why the compilation entirely happens on the background thread. So I know what your question is. You're saying, why doesn't the browser compile and keep the code somewhere?
So your worry is JavaScript loads only once for the first time. So that is where if you could improvise something, then it would really add some sort of improvements. But you are doing a compilation also. If it is for the subsequent record, it's a kind of, you are having a cache with file dependence and you are checking for the file dependence every time you want to see the cache validation. So that
yeah, I get what you're saying. Probably, there are areas that we can explore along those lines as well. But as you said, we'll have to manage versioning, and JavaScript, because of the nature of that language is so dynamic. You can never say what happens in a particular snippet of code. Like one particular aspect of JavaScript language which trips language designers or the JavaScript engine implementers is the eval function, right? So you can call eval, you can pass a piece of script, and you can form that script dynamically depending on the current runtime state, and you can never know what happens there.
When you also talk about comparison, I think we need to define the type earlier than where you said where type cannot hold to. So what is it?
I'm sorry, what was the question?
When you have compilation, then you definitely have a syntax page where you have to do the compilation, but
right.
you cannot do the compilation.
Right.
So JavaScript doesn't go in that way. You can define any type anywhere and
absolutely.
It's like kind of icon. So then how do you really know?
Yeah, so that's true, right? So you can write anything. Pretty much, it's a lot like HTML. You can throw pretty much anything at the HTML DOM, parser. It will give you a DOM. So yeah, so you can a lot of invalid code gets executed, but ultimately there is an internal representation of it, right? So you have your parser there. They're sitting and generating an AST. It has some logic, some heuristics. Probably those are some of the areas where you find differences between browser JavaScript engines. So the parser takes your JavaScript code and generates an AST, and from there on there's not a variance, right? So once you have your AST, you can pretty much generate the machine code from that. So yeah, I don't know. In fact, another colleague of mine asked me a similar sort of question. Now that you have native compilation, so why don't we compile the JavaScript and keep it on the server, right, on the web server, so that the next time it doesn't have to do the compilation again. So yes, but I don't know. It sounds like a very complicated thing. There are so many different form factors. There are so many different browsers. There are so many different architectures, right? And somebody might come on a.
If you go into that web server keeping compilation, then the other browsers won't.
There are lots of issues. So that's kind of similar to the same, like keeping a local cache copy also has complications. But I don't know. Maybe we'll see that. So I guess some of the key takeaways here is the compilation happens on the background thread, and you can see that one box here is missing. There is no marshalling. The reason is IE9's JavaScript engine has been kind of optimized for the web, right? So that's clearly the most important use case for the JavaScript engine. So the JavaScript engine runs as an integral part of IE itself. It's an in-process, like there is no marshalling required at all. All data, gets directly passed between the DOM and the JavaScript engine. So that has, provides huge benefits with regard to performance. So I just want to do a quick demo of, what this hybrid design, the fact that script actually gets loaded and starts interpreting first, and then as it encounters that, this little instrumentation that happens in the interpreter, which encounters or which identifies, right? So this particular snippet is actually getting called very often and is a candidate for compilation. So just a quick demo showing that. So let's see. So this is just a little page that I put together. So let's take a quick look at the source for this, right? By the way, the developer tools in IE9 is really awesome. If you haven't taken a look at this, I suggest you do. So I don't know if the thing is visible. Let me just zoom in. Wrong key. What is it? Control 1, 2, 3, 4. There we go. So this is a little piece of code here. So we have a long string there. Doesn't matter what it contains. So basically this runs a little loop here where it calls string.indexOf and looks for a particular substring inside that string. And it's a completely useless piece of code, right? It's very reflective of the kind of benchmarks that we have in SunSpider and all. So it's very synthetic. So basically it runs your this particular index of operation a lot of times. So it runs 50,000 times, and this entire function is called 20 times, right? So that's what is happening in this particular demo. So I just hit run, it executes that. So basically here we have the iteration, right, 1 through 20, and you have the time that it took, and it's been just quickly plotted on a graph. So there's a little pattern here that you can see, right? The first iteration took about 8 milliseconds, second one took about 9 milliseconds, and then subsequently you can see that it's like 4 and 5 milliseconds. It's kind of stabilized after that. So this kind of gives you a hint as to what is happening behind the scenes, right? So as soon as the browser downloaded the page and started running the script, it started interpreting it, and the interpretation took about, you can see that it took about 8 to 9 milliseconds, and then the instrumentation actually identified that this piece of code is actually getting called a lot, and then it's got compiled. So the time that you see after that, it's like an order of magnitude, right? So it's like double, right? So it's 4 and 5 milliseconds. So that kind of gives you insight on what's actually happening with the interpretation and the compilation. So this is kind of when you see this across many sites, and when you observe the pattern of JavaScript execution in IE9, first you have So this little graph here shows you, right at the top we have the, the time it took in IE8, and then this is the behavior that we see in IE9. So there is a big gap right at the beginning, right? So that's because in IE9 there is a brand new interpreter itself. Interpreter itself is rewritten and optimized. So you get some performance gain because of that. There is a little performance gain that we observe after that, first improvement with the interpreter. There are some optimizations that have been made with regard to property access. It turns out that in JavaScript, a vast majority of the time, what are people doing? People are accessing properties, right? So you're saying some object dot some property equals some value, or you're saying some object dot some method, right? So it turns out that 90% of the time you're just accessing properties or setting values to properties or calling methods through some other object. So property access is kind of key, and in IE9 some optimizations have been done specifically to target property access. So you get some performance benefits from that. Subsequently, of course, the compiled code then just runs on the CPU directly as native code, and you get performance benefits from that as well. So this is basically a graph that shows the WebKit SunSpider test results. So here we have IE8, Firefox, 3.6 version, 4, Chrome 11, Opera, and then IE9. Turns out that right now IE9's performance is the best of the lot. So, but one thing I'll probably draw your attention to is that the difference probably except for IE8 and Firefox 3.6 among all these browsers, the difference is not that much, right? So it's like 249 milliseconds, here is 276 milliseconds. So I think from an end user perspective, it really doesn't make that much of a difference. So I guess today we are in a phase at a point where the end user basically benefits, right? So all this competition is good because all Safari, Firefox, or Chrome, IE9, everybody, it's basically as web developers, this enables scenarios that were not possible earlier. Because you have such super fast JavaScript engines now, you can build applications that can leverage that. Basically this section talks about some of the type system enhancements that have been done in IE9's JavaScript engine. There are some drawbacks because of the fact, or because of the Java, but because of the fact that there are all these features, it tends to be slow as well. I can write a C++ program, compile it, and just run it. JavaScript applications tend to have a dependency on runtime, right? So many of these flexibility, many of the features are actually dependent on functionality that's available in a runtime. There isn't much of a type system, right? Pretty much any time you say type of something in JavaScript, what is the result you get?
Type of?
You say type of some variable, right? 90% of the time, what will you get? Sorry?
You get a type.
You get the type name, and what will be the type name most of the time?
Object.
Object. Yeah. So you have string number. 90% of the time you get object, right? So that doesn't really help, right? So you might create a person, class, you might create a shape, you might create a line, but all that is lost in the type system, right? If you say type of something, it will say it's an object. So not much of a type system, and because of that, there's an effect on how efficient it can be. With a language like C++ or C#, the compiler has complete knowledge about a type system, right? So when you're saying some object dot some member, the compiler knows exactly at what offset that member exists from wherever that object has been allocated. So the accessing a property in an object, right? So that's like I think I read somewhere that it's about 40 to 45 CPU cycles have to be spent to do a hash table lookup, compared to one CPU cycle for a direct memory access operation. So hash tables. So in IE8, everything was done through hash table lookups. It tends to be very, very slow. Like I was saying earlier, JavaScript programs tend to do a lot of property access. So let's take a look at, let's say you have this code, this bit of snippet here. So you have a function here which has, two properties that it accesses. We create an instance of it, initialize some values here. So one thing I'll call attention to is the fact that m.p3 here does not exist. It's not defined here, right? So here I don't have p3. So that's dynamically created. I'm creating a new object here, o.p2, p3, p4. There is no relation between object and foo. It's just another piece of code. So in IE9, there is this feature called as type evolution and sharing. So internally, what actually happens, right? Even though as a JavaScript developer there are no types, the engine internally keeps track of types. So as soon as it encounters that one particular line, var m equals new foo, internally, the engine goes and allocates a type called t0. Let's just call it t0. Then you say this.p1 equals 0, right? So immediately the engine goes and creates a new type, right? So if you have a C# or C++ background, it's actually creating a new class entirely called T1. And T1 inherits from T0, and this has a new field called P1. So you continue like that. As soon as it encounters P2, it actually goes and creates a new type called T2, and that inherits from T1, and that has P2. So when you say m.p2 equals 1, so here's where you get the benefit, right? So because internally there is a type, it's not a hash. There is a possibility that it doesn't have to be a hash table lookup anymore. It's at a fixed offset from.
So as a best practice, when we write in C# code, we always say that eliminate the hierarchies as much as possible, and here internally does that. So
What hierarchy? Oh, the class hierarchy.
Yes.
Okay, so that I wouldn't say that you have to exactly compare this with classic good design principles. This is basically an optimization feature that the JavaScript engine implements internally.
That's right, but when we talk about the comparison, it definitely will increase the lead time of compilation.
Right, but I guess what I'm saying is your comparison is probably wrong, because we are talking about good design principles. I'm talking about an optimization feature that the JavaScript engine has internally.
And the second question I have is like, in terms of JavaScript, when you have it, if you have some sort of error in one page, let's say you have 4 JS files, if you have some errors in one of the JS files, the other 3 are fine. You are referring that external as a JavaScript file.
You have 3 JS files, there's an error in one of them.
Yes. So still it works when I render that page in a browser. But let's say when I'm going to compile that, so will it work? If I have some error in my .js file itself, will it compile?
It wouldn't, right? So basically compilation is completely guided by the instrumentation that the interpreter provides in IE9. So the interpreter has to say that this particular function is on the hot path, a lot of time spent here, go compile it. So obviously if there are errors that would get detected right at the parser stage, that definitely would not be a candidate for compilation. So basically here the idea is to kind of show internally what the JavaScript engine is doing. So as it encounters these lines of code, so when you say this.p2 here, it actually it might look like it's not very efficient, but it actually reaps a lot of benefits later on. When we actually look at one pattern that the IE team, the JavaScript engine team, discovered when they analyzed a lot of JavaScript programs on the web. So continuing with that, right? So if you have M2 here, now here this particular access need not be a hash table lookup, right? It can, since the engine knows exactly at what offset P2 exists from wherever the object is allocated, it can be potentially, I'm not saying it will be, it can potentially be just like a native app. It can be a single CPU operation. So m.p3 equals 1, nothing happens because p3 was defined earlier, right? And then you have where O equals new object. So this is the type sharing piece that I was talking about, right? So when you say where O equals to new object, it goes into T0 again. So anytime you create any object which has a property called P1, there is a sharing that happens. So instead of creating a new type entirely, it goes ahead and uses P1 that is already existing. So this is continuing that chain there. So probably I won't spend too much time here, but exactly the same kind of sequence of operations are happening. So O.P2 goes into, creates a new type called T4, O.P3 goes into T5, and so on. So basically, what does this give you? So one of the optimizations that the JavaScript engine ships with is something called as polymorphic inline caching. I know that sounds pretty scary. Kind of running out of time. But basically the idea here is, what I was talking about, hash table lookups. So one thing that the JavaScript engine determined, when they were designing the engine, they determined is that even though there are, JavaScript is an extremely dynamic language. At any point in time, I can go and tack on any property to any object, as I like. It turns out that people actually don't use it like that. Probably it's because most JavaScript developers come from a background in a static programming language. Maybe that's the reason. But most people tend to use JavaScript like a static language. So they'll define types, they'll have specific properties, and they'll access properties. And that's how a vast number of applications out there on the web tend to be used. So polymorphic inline caching is basically an optimization mechanism that's been implemented in the JavaScript engine to take advantage of this. So now that you have this internal type system, and the JavaScript engine knows exactly exactly where the particular fields are allocated from a memory layout perspective, it can basically go and do that. So if you're interested in the exact details of this, we can probably discuss offline. It'll probably take half an hour for me to discuss that. But basically what happens is anytime you say some object or some property, as the engine keeps executing your code, there will be a point at which it will basically take advantage of the knowledge that it has of the type system, that is the internal type system, to basically remove the hash table lookup into a direct access. So it will be object, plus this particular offset is this particular field. So it becomes, super fast. So these are a couple of, very quickly I'll probably talk about in IE8's JavaScript engine, all numbers, right? Anytime you use the variable with a number, it was a 64-bit value, 64-bit quantity. It was a floating point number, even if you never used it like that. In IE9, they are 8-byte. They are not 8-byte quantities by default. It uses a 31-bit representation. Basically, it uses like a regular 4-byte integer, and as your program, deals with that number, like if it turns out that at a certain point you're actually using it like a float, then it will promote that into an 8-byte value. In IE8's JavaScript engine, all strings were represented as UTF-16 strings, basically 2-byte strings. In IE9's JavaScript engine, strings are by default UTF-8, basically 1-byte strings, and again, as there is a need, it might promote it into a 16-bit quantity. So this is probably the so this is great. So IE9's Chakra has all these enhancements. So what is in it for you as developers, right? So IE9's Chakra engine features is one of the most standards compliant JavaScript engines. So the standard for JavaScript as a language is something called as ECMAScript, the clunky name. But basically, ECMAScript, is the standard that basically documents what exactly the language contains. Like, what is the syntax? What all can you do with it? So, IE9's Chakra engine has complete support for ECMAScript by problem. Okay, not complete. So, for example, this is a test suite that Google has written. It's called Sputnik, and this basically tells you for IE9, Chrome 11, Safari, Firefox, recent versions of these browsers, how many tests have failed. There are totally about, I think about 1,500 tests in that suite. So IE9 actually has the least number of failed test cases. It's interesting, right? So Microsoft has invested all this effort to support ECMAScript 5. So why did they leave these 66 bugs there, right? But how much effort would it have taken to fix those bugs? So one of the reasons why this continues to remain is from a question of backward compatibility, right? So ECMAScript is like the ideal standard. The web is not ideal, right? So for example, right, one of the things is you cannot have a variable called eval. You can't say var eval according to ECMAScript 5, right? Turns out there are plenty of websites out there which say var eval. So if Chakra went ahead and implemented that, if you use eval, you get an error, then that would break a lot of sites. Right? So for that reason, you'll probably never see this going to 0. So what is the solution? So one of the things that is available now in ECMAScript 5 is something called a strict mode. So you can choose to run your JavaScript in an execution mode called a strict mode. So once you do that, then basically it becomes all the language features come into effect. And if you have any violation of these sort, like if I say var abstract, var eval, or there are plenty of aspects like that, then those actually get flagged as an error. So strict mode support is actually there in IE10. IE9 does not have strict mode support.
Strict mode is by DTDs?
Strict mode, no, not through DTDs. It's actually pretty elegant. And that was actually one of the overriding design principles in ECMAScript 5. If you look at the history of ECMAScript itself, it's pretty interesting, right? What happened to 4? Right? The previous version was 3, right? So 4 is not there. No, it directly jumped to 5. The reason is there was a lot. ECMAScript 4 was this huge project, right, to completely revamp the JavaScript language and kind of give it all kinds of fancy features. And then it turned out that it was not really working out. So that has been pushed into a new project called Harmony, and many of the features have been created into a new version called as ECMAScript 5. So how do you specify strict modes? You basically just have to declare a string. So if you have a function, let's say, and you want the function to operate in strict mode, right at the top you say in double quotes, use strict mode, semicolon, that's it. So what happens is basically it becomes completely backward compatible, right? So if a browser does not know strict mode, does not know ECMAScript 5 executes a script, basically you want to allocate a string and throw it away. Right? So whereas new browsers will, it has a meaning for that. So one of the overriding philosophies of ECMAScript 5 was not to introduce new syntax. So even though you have new features, it's basically using completely ES3 syntax. All the new features are made available. So ECMAScript 5 has enhanced object model support, value and accessor properties. Probably what I'll do is both this, and in the next slide I talk about some of the new features available with regard to JSON, arrays. I'll probably do a quick demo of all of these, so we can have a first-hand experience of what this looks like. What I'll do is I'll open a little console I have here. So alright. So basically, this is a little console I put together to quickly try out, quick JavaScript snippets. For example, I can go do this, and then as soon as I can hit Control Enter to run it. I'm a big keyboard fanatic. I hate using the mouse. So if you hit Control Enter, then you see the output that goes there. If I have errors here, then basically the errors get flagged there. So that's what this console does. So one of the things that I probably if you look at object model, now you have control over how dynamic you want your code to be, right? So JavaScript, you can create an object. You can you can do anything you want, right? So you can say var o equals this. I can say o.foo equals 10, and it's all peachy, right? So I can say o.foo, and it prints 10, right? So I never had to define that there is this type which has a property called foo. It has to be type integer, nothing. So now with ECMAScript 5, you can actually get to say exactly how dynamic something is. You can, for example, go and control whether somebody can go ahead and arbitrarily extend your objects or not. So that particular feature is called, there is this new method in your object class called as define property. So you can go and do something like this. So I create an object here. So this syntax here is basically, I'm creating an object. So you might go do this. So this is not the recommended way. The recommended way is to use object literals in this way. So what can I do? So I can go and do something like this. I can say object.define property. I can say what is that object. Let's say I define, foo, right? And as a third parameter, I can pass in another object. It basically tells you exactly what you can do. For example, right? I want to create a property called foo, which cannot be written to, right? If you want to create a read-only property. So let's say I say the value is 10, and I say writable is false, right? So if I say o.foo, it says I need to put a bracket. Not the bracket. Closing. You guys see where it is? There. Alright. So when you say print o.foo, it prints the thing. So now it has actually created a new property called foo on the o object, and currently the value is 10. So if I say o.foo equals 20, and then I say print o.foo, what do you think is going to print? 10. Okay, so it prints 10. Let me go put a clear at the top so we don't. Alright, so it prints 10, right? So what is happening is this particular statement kind of got ignored. The reason is because foo is a property where the writable attribute has been set as false. So that's another impact that it has in strict mode. So if you enable strict mode for this code, it will actually throw an error. So right now it silently ignored this, right? O.foo equals 20. In strict mode you get an error saying that you can't do that because it's a read-only property. So there are basically four attributes that you can set for properties. You can set the value, you can say whether it's writable or not, you can say whether it is enumerable or not, and you can say whether it is configurable or not. So basically what does that mean? Basically JavaScript has reflection. You have reflection capability in JavaScript, right? You can take an object, you can inspect what properties it has, and you can access values through reflection as well. So this basically controls that, whether a particular property will be visible through reflection or not. How do you do reflection? You say for var I in some object, and then I basically iterates through all the properties in that particular object. So if you say enumerable is false, that will not be visible through for var I in. So for example, if I say so let's say enumerable is true right now, right? So if I go and say this for var I in o, I just say print I. So this will basically tell me what are all the properties inside that particular object. So we get foo. It tells me that the object o has a property called foo. Let me go and set this as false. So now when I run the code, nothing got printed. So basically what happened is, because the enumerable is false, you can't enumerate through the object. And configurable is basically a property that tells you whether so now we have specified a configuration for this property, right? Configurable tells you whether that configuration can be changed. Can I go and make something that's enumerable, not enumerable? Can I go and delete this property completely, right? So in JavaScript you can say delete o.foo, and then foo will not be available on o anymore, right? So that's something that you can do in JavaScript. If you say configurable is false, you can't delete it. So basically, there is a push towards making the language, basically giving more control to you as JavaScript developers, right? So when you are defining a type system, you can do these are things that you are probably used to doing in a static world. Now you have similar kind of capabilities in JavaScript as well. You can so basically it gives you greater control over your type definitions. Some of the other enhancements as developers that we can leverage in IE9 is there is native support for Json. So how many of you here know about Json? Does anybody want to take a shot at what is Json? Right. So what is it?
It's a JavaScript object class, specify the data in a format which will directly convert to JavaScript.
Exactly. So it's basically a syntax in JavaScript. Oh, okay. I'll get through. It's basically a syntax that allows you to express any kind of object hierarchies, right? You can basically we saw an example of it, right? Oops. So basically the syntax that you see right here is basically JSON, right? So you can you can express complete a data hierarchy through JSON. In fact, JSON has become so popular now that it's used as an alternative for XML, right? It's a hierarchical data representation format, and we can use that for. So Ajax has really kind of driven the adoption of JSON, right? So now JSON is a pretty convenient format to send data to servers and receive data back from the servers in the form of JSON. So browsers, earlier you used to use eval for parsing JSON strings, right? Once you get a response from a server in the form of JSON, how do you convert an object? You say eval apply. You don't need to do that anymore. Now you have native support for it. Basically, there's an object called JSON. In fact, this was available in IE from version 8 onwards. So you can go and do something like this. So you can say, let's say you have a string like this, right? So I say name is, the only thing is this has to be exactly well formed. So I say name is who, let's say age is 10. Right? So that's basically a string, right? If I say print type of S, it will say it's a string. Now if I want an object from this, what you can do is you can say, let's say person equals json.parse of S, right? And now you can say print s.name. Oops. Person.name. So basically what happened here was, when you said parse and pass the string, it basically parsed your JSON and produced a JavaScript object out of it, right? So this is natively available in the browser, and you can do the reverse as well. So if you have so basically you have data serialization and deserialization. So I can take a object, I can say json.stringify of person. So what happened here was basically that object got, the reverse happened, right? So it took your object and converted it into a string. So that's really convenient. So since this is implemented natively, it's like excellent performance you get. So there are a lot of new features available in arrays, kind of totally out of time. Probably we can talk about it offline if you're interested. But I would really encourage you to take a look at some of these capabilities. So the array has a bunch of functionality here. For example, for each, that's a pretty common pattern, right? If you have an array, you want to iterate through every element in the array. So for each is a function that you can call on. That's a member method available on all your arrays. You can say array object.forEach, pass a callback function to it, and that function will be called for every element inside that array. So if you want to do some operation for every element array, for each is a great candidate for that. Index of is probably a pretty useful function now. If you are searching for an element in an array, you can use index of. Map and reduce are really useful. You can probably map basically allows you to execute a predicate on top of every single element in like, for example, let's say you have an array and you want to transform it, right? Let's say you have the simplistic example is you have an array with some numbers and you want to convert all of them to the square of those numbers. So you can use map for that. basically transforms, basically the result of calling the callback for every element in the array is used to construct a completely new array. Some useful functions that can add to string is trim. So now if you have a string with leading and trailing spaces, trim will allow you to trim that. Bind is an absolutely awesome piece of functionality. Unfortunately, we don't have time to take a look at it. Basically, it allows you to set the context, permanently set the context for a function to a particular object. Which what that means is inside the function, if you want to say this dot something, right? Now what does that this refer to? You can permanently bind another object as the context for that function through function's bind method. Day.now now gives you the current time in milliseconds from some date in 1970, January 1st, 1970. Date.product.to ISO string is pretty useful. Till ECMAScript 5, there was no standard way of representing dates, right? So each browser engine implementation, JavaScript engine implementation vendor was free to do their own thing in toString. So now you have a method called toISOString, which always, no matter which JavaScript engine is running your code, will give you a standard representation of the date. And there is a corresponding date.parse as well, right? So which can take your ISO formatted date string and produce a date object out of it. So those are some of the new features that are probably relevant from a developer point of view. You simply don't have time to look at this. So I guess I'm kind of done with the session. Probably one thing that I'll probably add on to that is there is this contest that you might be interested in IE9 called Dev Unplugged. Probably go to a site called beautyoftheweb.com. You can it's a pretty nifty contest. Like basically come up with a nice HTML5 website and you stand to win some really cool prize, lots of money. $9,000 is the grand prize. So that's it. Thanks for coming to the session.